Hello everyone, I am Professor Mayur Gohil. Welcome to the video lecture series on Simplex method. Today we shall be taking up another question in order to find the basic solution in an LPP. So let us see how to handle here. So I am taking up another question here. Question 2 is find the following. Find the basic solution of the following LPP. So here they have said that maximize z equals to 12x1 plus 8x2 plus 14x3 plus 10x4. This is the objective function given to us, subject to the condition. The condition is first is 5x1 plus 4x2 plus 2x3 plus x4 is equals to 100, and then they have said 2x1 plus 3x2 plus 8x3 plus x4 is equals to 75. And then there are non-negative conditions, and x1, x2, x3 and x4, they are greater equal 0. This is what they have given to us, and now we are expected to find the basic solution. Here there are few more questions are there. I'll show you. I have already made the table and kept. I'll show you. They have also said that find all basic feasible solutions then also find all non-degenerate solution. Fourth, they have said find optimal basic feasible solution. Okay, so all these things we have to find, and then we have to get the whole thing done. So let us see how to handle it. Okay, I'll just insert the space over here, and so that we can write down the basic theory. Okay, so here we have inserted the space, and now we will write down the basic theory. So what do we do over here in this case? Firstly, the first thing that we will do, we write down the question here. So given LPP is maximize z equal to 12x1 plus 8x2 plus 14x3 plus 10x4. Okay, this is what is given to us, and we write down the conditions which we had they gave us, we write down the same LPP again in our answer. 5x1 plus 4x2 plus 2x3 plus x4 equal to 100. And then here you have another condition which is given to us is 2x1 plus 3x2 plus 8x3 plus x4 equals to 75. These are the two conditions given to us, along with those non-negativity conditions x1, x2, x3 and x4 are always greater equal to 0. Okay, so these conditions are there. Now we mention all the things that are required here. So first thing we say here, how many equations are there? We have two equations and we have four variables. So again I'll insert some space because we will need something to write here first. Yeah, this much will be enough. Yeah, so having got our LPP, we now write down the required things that we need. So we write down here, we have m plus n as 4. Okay, these are the total number of variables that are there. So total number of variables is 4, and we have m, how many conditions are there? Two conditions are there, m equal to 2. Therefore n is equals to here 4 minus 2, which is equals to 2. Okay, now the number of basic solutions that we will have, the total number of basic solutions, therefore the total number of basic solutions is equals to m plus n cm. We had the formula, so that is 4c2. now that is basically 4 factorial over 2 factorial and then 2 factorial. That is going to be basically how much? It's going to be 4 into 3 and 2 into 1, right? So here it is going to be 6 answers we are going to get. Now we also write down here, because m plus n is the total number of variables. If you want, you can write down here that m plus n is the total number of variable. Here m plus n is total equals total number of variable, total number of variables, and n is total number of m is total number of conditions. M equals to total number of the main conditions. Okay, not the non-negativity conditions, it's just the main conditions. The rather total number of constraints, you can call total number of constraints, so which are only 2 over here. Okay, so n is the number of basic the one that we can set them 0, right? N is the one those whom we can set as 0. So here we will say so thus we can choose n equal to 2 variables to be 0. So now let us see. So and now we write down the following table shows the various basic solutions. Okay, therefore the following table shows the various basic solutions. Okay, now we make up the table now over here. So the table has these kind of columns that we had seen last time: serial number, non-basic variables, and the basic variable. So let us see how to handle them. So firstly, amongst all the table, first we are allowed to choose any two variables to become free, then the remaining we will choose. So now first we can choose, I'll write here the first one here is the first one. So the non-basic variables we have to set them as 0. So let us say I'll set here x3 equal to 0, and I'll set here x4 equal to 0. Okay, x4 equal to 0. When we do, what do we get? Let us see. x4 4, yeah. So we will do this, and now when we say x3 and x4 have become 0, so our basic variables become x1 and x2. So what are the two equations that we get over here? The two equations we will get: 5x1 plus 4x2 equals to 100. So first equation is 5x1 plus 4x2 equal to 100, and the second equation we will get is 2x1 plus 3x2 equal to 75. Now we will need to do the solving for this. So when we do the solving of this simultaneous equation, so we will get the value for x1. So x1 value we will get 0, and here x2 value we get as 25. x2 is 25. Okay, now we need to calculate the value of the objective function. So objective function value is going to be, because x3 x4 are 0, x2 is also x1 has also come to 0, and we have got only x2 with us, 25 into 8. So 25 into 8 is 200. So here we write it is 8 into 25, which is equal to 200, right? So this is what is the value we get. Now is this solution feasible? Yes, it is a feasible solution. So I'll write it red color over here. Yes. Is it a non-degenerate solution? No, it is not a non-degenerate solution. The reason is one of the value x1 is gone 0. Okay, so here it should become positive. That's why it is not a non-degenerate solution. No, the last column, is it optimal and feasible? We will write it afterwards. Here you can straightforward say it is not going to be the optimal. We will see how and whether it is feasible or not, but we will come to know later on. So now the second one we write, the second choice we will take. We take now here any one variable we can take to be 0. So I'll just take this here, and I'll now take x2 to be 0, let's say. So when I take x2 to be 0, my basic variables become only, here they would be x1 and x3. Alright, so x1 and x3 when we take to be 0, here I will get 5, we will get 5x1 and then 2x3 equal to 100, and here I will have 2x1 plus 8x3 is equals to 75. Now let us do the simultaneous solving of this. On solving them for simultaneously, you can do the in your calculator you get the value for x1. Here you will get the value for x1 as some number we will be getting. Let us see what value we get. I'll do the solving simultaneously. In the calculator, so let me do that more in that mode. I will have to take up. Yeah, so here when we have 5 and then 2 and then there is 100, I am doing in my calculator. So on this here you get 2 and here you have 8 and here we have 75. Okay, so on solving for x we get, now this is a very non-trivial number we get here. So x we are getting 325 divided by 18, and for x3 we will be getting 175 divided by 36. Now these are non-trivial unusual numbers we are getting. So let us calculate for the objective function. So on objective function when we calculate, what do we get? The objective function for x1 will now become with x1 value it will be 12 into 325 divided by 18 plus 14 175 divided by 36. So on performing this multiplication, let us see what do we get. 12 times 325 divided by 18 plus there is 14 times 175 divided by 36. Okay, so we get here our answer as 5125 divided by 18. Now is this a feasible solution? Yes, this is a feasible solution. Is it a degenerate solution? Yes, it is a degenerate solution because all the answers are positive. Okay. Now, whether it is optimal or not, we will see it later. Now we go for the next one, the third one. When we do again here, when we take the value, now what we will do, we will have x2, we have taken x1, x3 with x4 we have taken. Now we take here x2 and x3 to be 0. Let's take x2 to be 0, and now we take x3 to be 0. So the variables that are basic variables now, they are going to be x1, x1 and x4. Now the equations that we land up on, so they are going to be the equations that we will get. X1 and x4 are there, so it is 5x1 plus x4 is equals to 100. Okay, and then there is 2x1 plus x4 is equals to 75. Okay, so we get here this is easy solving here. So therefore x1 value will be, on subtraction you will get, it is 25 by 3, and x4 value you will get is 25 25 and then 50, and then this is 175. Here you will get 175 by 3. Okay, so again, whether we are going to get a we are having a degenerate solution for sure. So here it is yes. Is it going to be optimal? Obviously it is going to be optimal. Let us see how. But is it a feasible solution? Yes, it is a feasible solution. Let us see what is the answer we get. So answer that we will get over here is 12 into not 12. For x1 it is 12, yeah. So here it is going to be 25 divided by 3, and the for x4 we had 10, right? So it is 10 times 175 divided by 3. So it is, the final answer that we get is 2050 divided by 3. That is the thing that we get here. Now next way, here the fourth one we will see. The variable that we now going to put 0, we will take, let's say x2 and x3 we did. Yeah, so we now take x1 and x4 to be 0. So when we take x1 and x4 to be 0, so the variable that are remaining are going to be x2 and x3 to be our basic variables. So when we take x2 and x3 to be basic variable, what are we going to get? Let us see. x2 and x3, so 4, 2, 3 and 8. Okay, fine. So here we have 4, 2, 3, 8. Okay, x2 plus x3 equal to 100, and here it is x2 plus x3 equal to 75. Now this we will need to do solving in the calculator for getting the simultaneous equation answer. So let us calculate them in the simultaneous equation. So here we have 4 equals 2 equals, here it is 3 equals 8 equals, yeah. Now we get x2 x2 value to be 25. Correct? X2 value is 25 and x3 value, let us see what do we get. X3 value is 0. So we are now in a very easy position. We have got 25 into 8. Again this is 200. Okay, so again yes, this is a feasible solution, and it is no, it is not a non-degenerate solution. We will have to say no because one of the value is 0 over here. Okay, now the next one we will calculate. We have to get 6 answers, so we are done with 4. So let us do the next one, the fifth answer. When we calculate here, so now we can take here x1 and x3 to be 0. So let us take x1 x3 0. All possible combinations we have to take. So here we are getting the equations as the basic variable will be x2 and x4. So on that case, x2 and x4, the basic variables are that, so 4x2 plus x4 equal to 100, and here is 3x2 plus x4 is equals to 75. Okay, so our work in this mode, we will now have to calculate again that x2, we can see it is clearly 75, right? X2 is 75, and here we will be able to get the value for x4 also. No, x2 is 25, sorry, not 75, 25. So x2 is 25 and therefore x4 is 0. So again when we calculate our answer, here it is 200, and yes, this is a feasible solution, but it is not a non-degenerate solution, so the answer is no. We have got here these answers. Now the last answer we will see. The last answer here is for the sixth case, that the remaining case which we will take here. The remaining case will be x3 and x4 to become 0, right? No, we have taken x3 x4 to be 0. We will take x1 x2 to be 0. Okay, so when x1 and x2 are 0, so here the basic variables in that case are x3 and x4. Here when basic variable x3 and x4, what are the equations we are having? Let us see. So the equations in that case, again we will need the coefficient 2, 1, 8, 1. Okay, so here we will be having 2, 1, 8, 1, right? So 2x3 plus x4, and here it is plus x4 here and x3. This is 100 and this is 75. Okay, now we calculate the using so we solve for the solution. Now when we solve for the solution over here, we will get some answer. So let us see what answer do we get. So here it is 2, 1, here it is 8 and 1. Okay, so now when we solve this, we get x3 to be negative minus of 25 divided by 6, and x4 what we get is 325 divided by 3. So obviously this is not a feasible solution. We are not even going to check because x3 should be positive. So here we say no, nothing, we cannot apply for the optimality. Moreover, this is not a feasible solution, so not even a degenerate solution, and it is not even optimal. So now we have got all these solution, of which we have to check which one is going to be the maximum value. So let us check the values for which the maximum answer comes. So 200 is one answer. So let us see 5125 divided by 18 gives us somewhere around 284. Okay, so that is 284 is some answer here. So I'll just write down here. Oh, okay, so I'll just put some answer in purple here. So this is 284 point something something. Okay, and here 2050 divided by 3, this is 600 and something, 683.333. So obviously this is the maximum answer because we wanted to maximize this. So yes, this is the maximum answer, and the rest all are no. Okay, so this is how we get our optimal solution. Optimal is the one that which maximizes our answer. So here all rest are no for the candidate. So only candidate that will work for the solution, so we get our answer here. Now so the best answer over here, what is the answer, where does this thing happen to work, let us see. So we will have to write our final answer. So the final answer is that our answer here we got is at this value. X2 x3 are 0, x1 and x4 were working out, right? So x1 value is 25 by 3, x2 is 0, x3 is 0, and x4 is 175 by 3, and the maximum value, or we can write in short like this, Z max. Okay, Z max is over here is 2050 divided by 3. Okay, this is the value of Z, which is maximum. So we got all these solutions. Now you can see that this method, once you go through, so what you have to do, first you have to find n. Once you are able to find n, you are then able to choose the number of variables which you are going to set 0. If you don't find n properly, you will not be able to do the solution. Okay, so here we have done with the example. I hope you have followed this example. Now you can see that this method is very basic and has a certain limitations, that we cannot find all the time all the solutions, and we the reliability is slightly dubious, because all the things, some infeasible solutions could be there, unbounded solutions could be there, there could be multiple answers for which we are getting the the same values. So some more analysis is required. So now then we come to another main part of this method, which is simplex method. So in the next video lecture, I will be explaining the details how to handle simplex method with different procedures. Okay, so till then, keep solving good amount of mathematics. I hope you have followed this example. Please go through it once and do considering subscribing my channel and hit like button. It does motivate me. Do give your feedback in the comment section. I would be happy to help you if any difficulties you have faced in this problem. Thank you.